In this lecture, we are going to learn about multiple regression. So what is multiple regression? Multiple regression, as its name suggests, is a method of regression analysis in which we see the effect of multiple or many independent variable on one dependent variable. So look at this data set that I have taken from the SPSS sample data set that you can locate in your C drive. This is the employee data set, and I have a data of employees which are arranged according to their ID, gender, birth date, education, job category, salary in the beginning at the time of joining, and job time, previous experience, and whether they belong to minority community or not. Now suppose in this data set I want to find out what exactly determines the current salary drawn by the employees. It could be their experience, it could be also their salary at the time of joining, because it's logical to assume that those employees who were drawing higher salary at the time of joining, they will also draw a higher salary currently. Also we can guess that experience of the employee also going to contribute their salary that they are drawing. Apart from this, we have also the education. So education is again important criteria for determining the salary. Those employees who are highly educated, we can presume them drawing higher amount of salary as compared to those employees who are less educated. Similarly, we can also guess that salaries drawn will also be affected by the position held by the employees. In our case, we have the three categories of employee: clerical, custodial employees, and manager. And we may make a guess that managers are drawing higher salary or would be drawing higher salary as compared to clerical or custodial employee. But if we want to test this assumption that job category, education, or position of the employee, or the salary at the time of joining the organization, they are the causative factors or they are the influence factors in the current salary drawn by the employee. So in that case, we have to run a multiple regression analysis. So the idea of multiple regression analysis is very clear. When you want to predict one dependent variable, in our case it's a current salary, by many independent variables like say education, job category, beginning salary, job timing, previous experience, then you can perform a multiple regression analysis. When you perform a multiple regression analysis, your variables must be logically selected. For example, do you believe that being in a minority status does affect the salary of a person? Well, it may or may not. So it's interesting to say this, but theoretically, if you find any justification that minority affiliation of the person may affect his or her salary, then you can include that variable as well in the multiple regression analysis. Or if you want to include all the variables in your multiple regression analysis, you can, and the SPS is going to tell whether this variable exercise a significant influence on the dependent variable or not. So the model of any multiple regression is very simple. You have to select a dependent variable. Generally we denote our dependent variable by the symbol y, and then you have many independent variable, and we can call them x1, x2, x3 till we can have xn. And then we are going to get the coefficients by applying the multiple regression analysis. So suppose those constants or coefficients are alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 till alpha n xn. And when you make a prediction, now you are predicting the y on the basis of these x variables from x1 till xn. You are going to make some amount of error because we cannot always account or find all those variables who will completely in joint predict the y. So there is bound to be some error term. So again we are going to find that out, and apart from that we are going to have a constant as well in our regression equation. So there is a constant. So that's our typical theoretical regression model. Now I have used the word alpha but most typically people use the word beta. So we can again rewrite the equation as beta 1 x1 plus beta 2 x2 plus beta 3 x3 till we have beta n xn, then our error term plus constant term. And you can fairly guess these betas are the standardized regression weights that we are going to get after the regression analysis. Now what was our case? We wanted to predict the current salary of the employee. So we will write our multiple regression equation as current salary is equal to beta 1. Now let's take one variable as the beginning salary of the employee. So beta 1 into beginning salary. Then we can take our second variable as the education. So education category into beta 2. So I need to write beta 2 here. So beta 2 into education category. Then third variable we may take as a experience. So for that we are going to get a third coefficient, that is beta 3 into experience. So we have built a simple model by taking into 3 variables. If you want to take into count more variables, you can, and you can make a lengthy or complex regression model, and then you are going to add your error term and then constant. So that makes our regression model clear. And you can see in case of multiple regression analysis, we can take our independent variable as either a nominal variable or a metric variable. So independent variable could be metric or non-metric, but our dependent variable in case of multiple regression analysis or linear regression analysis or even hierarchical regression analysis that we will do later should always be metric. So this should always be metric, while this independent variables, they could be either metric or non-metric.